Okay, the Pythagorean Theorem shows a relationship between the sides of a right triangle. So a right triangle is defined as a triangle, and one of the angles is a 90-degree angle. Okay, the two sides that make up that right angle we call legs. So that's a leg, that side is a leg, and this side is a leg. And the opposite of that right triangle, we denote this right triangle with a little square down here, that's called the hypotenuse. Hypotenuse. Okay, and the relationship is that the square of the sides, the sum of the squares of the sides of the legs equals the square of the hypotenuse. So let's go ahead and show you. Let me give you an example. We have a triangle here. Let's say I have one leg that has side length A, and the other leg has a side of length B, and the hypotenuse has the length of C. So it's important that you be able to identify the three different sides of a right triangle, right? The two sides that make up the right angle are called legs, and then the third side is called the hypotenuse. So the relationship is that if I square one leg and then I add it to the square of the second leg, that equals the square of the hypotenuse. So this is important for right triangles. So this basically means that if we know two sides of a right triangle, then we can always find out the third side. So let's do a couple examples. Okay, let's take a look. Let's just say we have a right triangle here. And we'll write our relationship up here. We know that the square of one leg plus the square of the second leg equals the square of the hypotenuse. Okay, so let's take, let's say we have a right triangle. One leg has a length of 3 meters, say, and the next leg has a length of 4 meters. We can figure out what the length of this hypotenuse is, right? So we want to find out that length. So the relationship, this is like my A, this is like my B, so I can say my 4 squared plus 3 squared equals C squared. So that gives me 16, 4 squared is 16, plus 9 equals C squared, or 25 equals C squared. So now what we need to do is we want C, we don't want C squared, right? So we use the square root function. When we take the square root, basically we're looking for two numbers, two identical numbers that multiply out to give me 25. So I take the square root of 25, and I know that 5 times 5 gives me 25, so C, the third side, the hypotenuse, is 5. And in our case here, C is 5 meters, because that's the unit that we used. So now we don't always have to be given just the sides. We could say, let's say our right triangle is kind of flipped around like this, and let's say we know that one leg has a length of 5, and let's say this time the hypotenuse is 13. Okay, so let's again write our relationship here. A squared plus B squared equals C squared. Okay, so now we need to identify the legs. This time we don't know this side, right? And that's actually one of the legs. So let's say that this is the same as x squared. That's one leg. My other leg is 5, so I have 5 squared, right? And that equals the hypotenuse squared, which is 13 squared. Okay, so let's go ahead and expand that out. We get x squared plus 25 equals 169. 13 squared is 169. Subtract 25 from both sides, and I get x squared equals, remember I take 25 from both sides, so I get x squared equals 144. So I'm looking for a number. Right? If I take the square root of x squared and I take the square root of 144, I'm looking for a number that when multiplied by itself gives me 144, so that's 12. So the third side, the leg that I'm looking for, is 12.